Hey everyone, welcome to homework 2.6. I'm going to go over the homework and then I will go back up to the bonus part of the classwork from today. So this graph represents Andre's distance from his bicycle as he walks in a park. Okay, so this is, again, his distance from the bicycle. So let's say he parks his bike here and then he's walking away from it. And at different points, he's further from the bike or closer to the bike, right? So if he comes back around, then he's now closer to the bike. So this is measuring the distance that he is from the bicycle as he's walking. All right, so true or false, the graph has multiple horizontal intercepts. So I see a horizontal intercept here, and I see one here. So this is true. Yes, that is accurate. Number 2, a horizontal intercept of the graph represents the time when Andre was with his bike. So when it crosses this axis, is that when he's with the bike? So that would be when there's 0 distance between him and the bike, so that is also true. A minimum of the graph is 17,1. So the lowest point on the graph is actually at these horizontal intercepts. 17,1 would be about here, and that is a dip in the graph, but it is not the minimum because these points here on the x-axis are lower, so this is false. The graph has 2 maximums. So here we have a maximum here. That appears to be higher than this peak right here. And so this only really has one maximum, which is right there. About 21 seconds after he left his bike, he was the furthest away from it at about 8.3 feet. So the furthest that he was at 8.3, and that was somewhere here. And it says about 21 seconds. That looks to be about accurate. 21 point some seconds, so we can say true at about 21 seconds. Number 2, the graph represents the temperature in degrees Fahrenheit as a function of time. So here's time on our x-axis, the temperature here is what's changing. Tell the story of the temperature throughout the day. Identify the maximum and minimum of the function and where the function is increasing and decreasing. So we're going to say, right, thinking about what time is here. So this is probably around 9 a.m., right? Because based on these increments, maybe a little bit less. It's not marked very well here. But so at the start of the day, we'll say, it is colder. We don't know the exact temperature, right? It's colder here. And it gets warmer until what time? Until about noon. And then it continues to get warmer, but at a slower rate. And then gets warmer at a slower rate until 3 p.m. After 3 p.m., so you finish the story. After 3 p.m., what happens to the temperature? Until 7 p.m. and then until 9 p.m. Now notice here, the slope is steeper, so that's how I know that it is getting warmer faster. And then it's still getting warmer here, but at a slower rate. So similarly, here it's getting colder, but it's getting colder from 7 to 9 at a faster rate because this is steeper. It's a steeper hill, right? So if you can imagine, right, someone rolling a ball down the hill, it would go faster down here. And so it is getting colder faster between 7 and 9 p.m. All right, so identifying the maximum and minimum of the function, and I keep hitting erase, and there we go. And where the function is increasing and decreasing. So it increases from beginning to 3 p.m. and decreases from 3 to 9. And then the maximum happens at 3 p.m. we don't know what the temperature is, but we know that's the highest. And then the minimum is at start. And it looks like these are about the same here. So at start and 9 p.m. Yeah, it looks like they're about the same there. So these points here would be our minimums. All right, number 3 says match each feature of the situation with a corresponding statement in function notation. So the maximum height is here, and that is at 4,16. So an input of 4, and so that would be 3 right here. A minimum height we have, which is down here, and that's at about 1.5 seconds. The height staying the same is between 7 and 8. So notice it's not changing there. And so this says h of t equals 6. So that height is 6 here. And that is between the time of 7 and 8 seconds. So that's here. And then the starting height is h of 0. That input is 0, and then the height is 7. And so that would be this one right there. All right, here are the equations that define the 3 functions. All right, so for this one, you have 3 different functions, and you have to input 100 in each of them and see which one is the largest. So we're going to substitute f of 100 equals 4 times 100, which is 400 minus 5. That gives us 395. We have g of 100, which equals 4 times 100 minus 5, which will give us 4 times, remember you do the parentheses first, so 4 times 95, equal sign there, okay? And then you're going to do h of 100, which equals 100 over 4 minus 5. I can already tell that this one's going to be the smallest one because 100 divided by 4 is 25 minus 5 equals 20. And so then your determination is between the first two. If you do 4 times 95, you will get 380. And so f of 100 is the largest function when the input x equals 100. So then it says which is the largest when we have a negative 100. Well, knowing that this one was going to be the smallest, if that then becomes a negative number, my guess is that that will be the largest. But let's try f of negative 100 equals 4 times negative 100 is negative 400 minus 5 equals negative 405. G of negative 100 equals 4 times negative 105, which is going to be negative 420. And then this one over here will give us h of negative 100 equals negative 100 over 4 minus 5, which is negative 25 minus 5, which is negative 30, which as predicted, this is the largest now because these are very, very negative numbers that we're looking at here. Okay, and so in this case, h of negative 100 is going to give us the largest value. And then the last one is actually asking you to do the same thing with fractions. All right, so that is going to stretch your brain just a little bit. I'm going to show you if we do f of 1 over 100, you can get 4 over 100 minus 5. Now, if it's helpful for you to put that in fraction form, decimal form, you can, but you get 0.04 minus 5, which is going to give you negative 4.96. All right, that gives you a solid number to look at. If we do g of 1 over 100, again, putting that 1 over 100 in decimal form is 0.01. So 4 times 0.01 minus 5 is negative 4.99 times 4 is negative 19.96. And then lastly, h of 1 over 100 gives us 0.01 divided by 4 minus 5. So 0.01 divided by 4 is 0.0025 minus 5 is negative 4.9975. So this is actually very close, but this means that our first one is actually the largest one. F of 100 is the largest one, as this one's going to be a little bit more negative because we're multiplying this by this 4 here. All right. Now, part A, B, and C are asking you to look at this one, and it's using an exponent. So f of 2 equals 2 squared. 2 squared is 2 times 2, which is 4. F of 3 equals 3 squared. 3 times 3 equals 9. And then it says, explain why f of 2 plus f of 3 does not equal f of 5. Well, if I do f of 2 plus f of 3, I get 13, right? But if I do f of 5, we would get 5 squared, which is 5 times 5, which equals 25. So these two are not equal to each other. All right, Priya bought 2 plants for a science experiment. When she brought them home, the first plant was 5 centimeters tall, and the second plant was 4 centimeters tall. Since then, the first plant has grown 0.5 centimeters a week, and the second plant has grown 0.75 centimeters a week. Which plant is taller at the end of 2 weeks? Explain your reasoning. So let's create functions for these. We have plant A, and this is a function of time, right? So how long it has been going, how long it has been growing. And plant A starts at 5 centimeters tall, and then it continues to grow 0.5 centimeters per week. Plant B is 4 centimeters tall, but it grows 0.75 centimeters per week. So at the end of 2 weeks, if I substitute this 2, I would get 5 plus 1 equals 6. And at the end of 2 weeks, 0.75 times 2 gives us 1.5, plus 4 is 5.5. All right. So in this case, plant A is taller. And you can show you're showing your reasoning here by showing your math. It says which plant is taller at the end of 10 weeks? So if we do 5 plus 0.5 times 10 equals, and 4 plus 0.75 times 10 equals. All right, so you have 10 times 0.5, which is going to give you 5 plus 5 is 10. So now it's 10 centimeters. And then we have 10 times 0.75, which is going to use 7.5 plus 4 is 11.5 centimeters. So after greater time, even though plant B starts off smaller because it's growing faster, plant B will be taller at the end of 10 weeks. Priya represents this situation with the equation 5 plus 0.5W plus 4 equals 4 plus 0.75W, where W represents the end of week 4. What does the solution to this equation, W equals 4, represent in this situation? So because she said these equal, this will be when, so this represents the height of the plant. So this will represent when the 2 plants have the same height. Letter D says, what does the solution to the inequality? This would be plant A versus plant B, the height of these plants. So this is when plant A is taller than plant B. All right, so that's it for the homework. Your code word for today will be spider plant, because we talked about plants, spider plant. And I'm going to go back to this part. This part, again, was a bonus. You don't have to do it, but I encourage you because it's good practice. It says the following graph shows the distance traveled by a school bus based on every morning from 6:30 to 7 a.m. What do the flat sections of the graph represent? So this is the bus is traveling distance, and then at these points right here, the bus has not increased its distance, but time is still passing. So these flat sections are when the bus has stopped. It hasn't increased its distance at all. It stayed the same for those periods of time. The steep sections of the graph are the bus is moving. And remember, the steeper, then the faster. Which is the best estimate of the bus's average speed? 17 miles per hour, 20 miles per hour, 34 miles per hour, or 50 miles per hour? Well, the bus has traveled approximately 20 miles in 30 minutes, right? So actually maybe a little less. Let's say 18 miles in 30 minutes. So that would be 9 miles per hour, right? Because if they can travel 18 minutes, or sorry, the opposite. If they can travel 18 miles in 30 minutes, then they could travel 36 miles in 1 hour. So I would actually say that this is probably looking at about 34 miles per hour, seems about accurate here. Estimating that this point, this ending point that it's traveled is at about 17 or 18, right? And it's out of 30 minutes, so it's not 17 miles per hour, because that's out of 30 minutes. It would need to be double that, because it's going to go for, if we were to extend that a full hour, it would go another 17 to 18 miles. Why doesn't the path of the line ever go down? So this is measuring the distance that it travels, and so it can't decrease the distance traveled. Now, if instead it was measuring how far it is from a certain point, so if it was measuring how far it is away from the school, then it could go down because it could get closer back to the school. But this is measuring the distance that it has traveled instead. All right, for this one, we're listing the x-intercepts, so that's where it's crossing the x-axis. Here, that's not quite 0, 0. We'll say like negative 0.1 comma, or sorry, yes, negative 0.1 comma 0. And then we have another one over here, which is 5 comma 0. And just about there, right before the 8, we'll say it's 8 comma 0. The y-intercept, there's only one here, and that is right here. Just point that out right here, just above the 0 as well. So in this case, 0 comma maybe 0.1 or so. It says for the interval negative 4 to 3. So from here to here, from negative 4 to 3, the function is going up, so the function is increasing. From 4 to 5, so that's from here to here, shoop, the function is decreasing. For the interval 0 to 9, so from here to here, the minimum value is this point right here. We'll say it's about a little bit before 6, so maybe 5.75 comma negative 2. And for the interval negative 4 to 9, so the whole thing, right, from here to here, the maximum value is right here, and so that's about 4 comma 4. And then is the graph discrete or continuous? You don't need to worry about this. This is continuous, but don't worry too much about that yet because I didn't go over that. And is it linear? Is it a function? So this is not linear. You can tell it is not forming a line. It's quite a wavy situation there. Is it a function? So if we were to do the line test and draw a vertical line, whoops, oh goodness, through any given point, it's not going to intersect. Even here, it's only going to intersect one time. So yes, it is a function. All right, that's it for today. If you have any questions, feel free to reach out and text. Happy homeworking and see you tomorrow.